Now let's look at addition and subtraction of matrices. The idea behind adding and subtracting matrices is that for the addition to work or for the subtraction to work, the matrices, first of all, need to have the same size. If the matrices don't have the same size, then we cannot do addition or subtraction of matrices. Now, if you're adding or subtracting the matrices, you will just add the terms in the same position to one another or subtract them depending on the problem. So in this case, in example 2, we are expected to add the matrix A with the matrix B. The matrix A is -5, 2, 3, and -4. And we would like to add it to the matrix B, which is 6, -5, -3, and finally 2. So first of all, what's the size of this matrix? It's a 2 by 2. What's the size of this matrix? It's also 2 by 2. So we can add. Yes, we can perform the addition. Now, how do you actually add them? Very simple. You add these two numbers together, and then these two numbers together, and then these two numbers together, and finally the last two numbers together. So basically, everybody with their own position. So -5 added to 6 will be at the end 1. 2 and -5 when added, it will be -3. 3 and -3 when added, it will be 0. -4 added to 2 is going to be -2. And that's it. So where did the 1 come from? It came from the -5 and the 6 when you added them. The -3 came from the 2 and the -5. The 3 and the -3 gave me a 0. And finally, the -4 and the 2 added up to -2. And that's pretty much it. You just finished the problem. This is your solution. Okay, pause the video for a second and see if you can add the next couple of matrices, this one and this one. See if you can get them done real quick. So I hope you got the right answer. So the first matrix was -8, 6, 3, -4, 5, and 6. And the second matrix was zeros everywhere. And that's a special thing. When a matrix has zeros everywhere, we call it the zero matrix. So since there are zeros throughout the whole matrix, everywhere in every position, none of the numbers is different than 0, we call that the zero matrix. And it's also known as the additive identity. Basically, this is the 0 of the matrix world. Remember, in the real world, if I add 0 plus 5, I get the same number back, for example. If I add 0 minus 3, I get the same thing back again, -3. So the zero matrix has that same job. No matter what is added or subtracted from it, the answer is always going to be 0. Okay, let's take a look at how to subtract. And subtracting is also very straightforward. Again, subtracting A minus B is pretty much the same procedure like adding. You're gonna write down the numbers first of all, and the order here matters. So be careful with the order. The matrix A has to go first, then the matrix B, 6, -5, -6, -3, 2, and then 5. And again, when you're adding, you're gonna go turn by turn. The -5 and the 6 go together, the 2 and the -5 go together, the 2 and the -6 go together. But keep in mind, this time we're subtracting. So be careful when you're subtracting. So -5, -6 is going to be at the end -11. And that's basically finished. Now, 2 -5 is going to be 2 plus 5, which is 7. And then again, 2 minus -6 is going to be 2 plus 6, which is 8. Okay, so again, the -11 was the sum or the difference in this case. The 7 was the difference. And finally, 8 was the difference of the top row numbers. Then again, we do the same thing. 3 minus -3 is going to be 3 plus 3, which is 6. And then -4, -2 is going to be -6. Then finally 7 minus 5 is going to be at the end 2. And that's pretty much how that's going to end. This is the solution. Now, subtractions don't have to be done by hand. They can be done with calculators. So if you want, I'll show you how to do the next problem with the calculator. So first, let's type these numbers into the calculator in matrix A and matrix B. Okay, before I do that, let's take a look at the size of the matrix. This one has 3 rows, 2 columns. So I'm going to have 3 by 2. And this one here has 1, 2, 3 rows again, and it has 2 columns. So it's a 3 by 2 again. So we can add it or subtract it from one another. Okay, so here we go. I'm going to go into the matrix menu and go to edit. And I'm going to put the matrix A first in the letter A. I have some data from last time we did a problem, but I'm going to delete it by clicking 3 and 2. It automatically adjusts, it kills off a bunch of them, and it leaves me with a brand new matrix, and I'm just going to overwrite the old numbers. So it jumps, every time I hit enter, it jumps to the next position. All I have to do is put the numbers in. So that's the matrix A, and now it's saved. I'm going to quit, and I'm going to go again, second matrix, edit again, and this time I'm going to be putting matrix B. So I'm going to use a different letter this time, letter B, so second option. And this one is a 3 matrix by 2 matrix. And again, the numbers are -3, 5, 1, -2, 4, -3. And that's it. So now I'm going to quit. And I need to subtract the matrix A from the matrix B, or the matrix B from the matrix A. Whatever, it doesn't matter. I'm just going to click, in this case, I want to do A minus B, so I'm going to click second matrix, then A minus second matrix B, and then hit enter. And there it is. That's the solution to the problem. You don't even have to do it by hand. You can just copy it off the screen. It's good to notice that when you're adding and subtracting, the size of the answer is the same as the original size that you started with. So that does not, addition and subtractions does not change the size of your matrix. When we later multiply matrices with other matrices, the size will be changed. But for now, the size stays the same. Now finally, the last problem has A, which is again a 3 by 2, and B, which is in this case 3 by 1. So what does that mean? That means A minus B does not exist. We cannot subtract these two matrices. Why? The size does not match. They don't have equal size. The size is not the same. That's why we cannot do the difference or the sum. As a matter of fact, if you try to put this in your calculator, the calculator is going to say some sort of an error.